Good afternoon, this is Professor Arnold, and today we're going to talk about area under the normal curve. And of course, the reverse. That is, if you're given an area, how do you find the point x or the z value that is either left or right of that point relative to the area? So, let's bounce right into it. So in general, you would be asked to find the area under the normal curve, and the problem would read something like, given a normal distribution, and sometimes we use this notation which denotes a normal distribution, n open paren mu comma sigma close paren, where the mu denotes the mean and sigma denotes the population standard deviation. Find the area under the curve that is between these two values, x1 and x2. So in any problem, you have the statement of the problem, you have the solution, which would be the steps for you to arrive at the answer, and then finally the answer. So the first step in doing a problem like this is to draw a picture. So we draw a normal curve. So you come up like this, come around, you need some axes. Look at this point right here. So the area that we're interested in is between these two lines. So I need to put in an axis here, x-axis, and in the middle would be my mu, and to the left is my x1, and to the right is my x2. Now it doesn't have to be that it's on the left side, the x1 is on the left side and x2 is on the right side. It could be anywhere, okay? Substitute in the TI-84 calculator function. That is not to say that you cannot substitute in the TI-83 calculator function, but in some of my lectures I do refer to functions that are not on the TI-83. So as a habit I keep saying TI-84, but in this particular case TI-83 would do just as well. So the function, most of the functions, they take arguments, and the arguments in this case is the first point, the point to the left, followed by the point to the right, followed by mu, followed by sigma. If you did not put in mu or sigma, you will get z-scores. Okay, if you want the x values themselves, you need to tell the calculator what the mu and what the sigma was. So let's do a real live example. We want to find the area between 2 points, but this time I will actually give you 2 points. So the first example is under the standard normal distribution. In other words, the standard deviation is 1 and the mean is 0, using that notation that I mentioned before. We're asked to find the area under the curve that is between z equals to negative 1.5 and 2.5. Step 1, draw a picture. So you'll see this in every step. We draw the picture, you come up like this, you come around again, and then you need to shade the area that we're talking about. So to complete this picture, we need the x-axis. We put that in, and now we're going to shade the area that we want, and I'll show you the x values that we're looking for. In this case, they're z values. So the z values are minus 1.5 and 2.5, and since it's a standard normal curve, in the middle you will have 0. So the next step is to substitute in the TI-84 calculator function. The function requires arguments and in a particular order. So x1, or in this case z1, is to the left, in other words the first point in the substitution. So that would be minus 1.5 comma 2.5 comma 0 for the mean and 1 for the standard deviation. That gives us a value of 0.9270 to 4 places of decimal. I put 4 places of decimal because in most of your exercises you would be asked to put this to 4 places of decimal. The next example, example 2, the area left of a point. So problem, given a normal distribution, here the mean is 1000 and the standard deviation is 150. What percentage of data is below 900? So you see the data, the the area is to the left. So we draw a picture and we're going to show that area to the left. Here is my x-axis. So my area to the left, I'm going to mark like this and shade it. I need to enter in the top of my curve, so I do that. And now I go to the next step, and that is to use the TI-84. But remember now they ask you for percent in this particular case, so we would have to convert that value that we get, which would be a decimal expansion, we'll have to convert it to a decimal, to a percentage, sorry. And to do that, you need to multiply by 100%. Not by 100, but 100%. So the percentage that we are looking for is a normal CDF, and we need to go from negative infinity to 900, and then we need to tell the calculator that we are giving it the x values, the data values, so it needs to know what the mean and standard deviation are, and they are 1000 and 150, and then we multiply by 100% to bring it to percentage. Now the left point in this case is minus infinity, so we need some number to represent, a finite number to represent negative infinity, and we choose negative 1 E99. Don't use something like 9999 because sometimes the data values could be high values, and 999 could just be one of the values, so you will get an incorrect answer. So let's do that for this question. In other words, substitute the negative 1 E99, comma 900, put in the mean and the standard deviation. When you compute that, then you multiply by 100%, and that will give us 25.25%. So the answer to this question is 25.25%. Now let's go to the next question, which is another example where this time the area is to the right of the point. Suppose that adult IQ scores are normally distributed as n, mu is 100, and standard deviation is 15. Find the probability that an adult chosen at random has an IQ score greater than 120. Well, again, we go to the solution. First step of the solution is to draw a picture. So we're going to draw a picture. That's my normal curve right there. Put in some axes, put up some dividing lines here, and then shade the area that I'm concerned about. It's to the right. The mean is 100, so that's in the middle. 120 is the point in question, so that's on the right side of 120, and again we shade the area that we're looking for. So when we substitute in the TI-84 calculator function, we get normal 120 1E99. This time it's a positive infinity, so we use this approximation. Not that there is an approximation to infinity, but think of it as being representative of infinity in a finite way. So 100 is my mean and 15 is my standard deviation. Again, to 4 decimal places, we get 0.0912. Now, so that's for area under the curve. Now we want to know, suppose we did know the area under the curve, what is the point? If we know the area under the curve is to the left of a certain point, what is that point? Or even if it's to the right, what is that point? Well, that can be done also. And in general, you'll be given a problem like this. You're given a normal distribution, n mu sigma, and an area under the curve that is left of a given point. And like I said, it could be to the right also. But if you remember the basic one, which is to the left, and that's because the calculator function gives you the point on the x or the z-axis if it knows the value to the left. So again, we're going to draw a picture, same picture we draw every time, to indicate what we have. And in this case, we have an area A to the left. That's what I have shaded. And let's put in the axes. You have x1, and then you have mu in the middle. Now x1 doesn't have to be where it is there on the left of mu. It could be on the right. So the step 2 is simply to substitute in the TI-84 calculator function. and it needs 3 arguments. Inverse norm takes the argument A, mu, and sigma. A is the area to the left. A is the area to the left. I'm going to stress that every time. Okay, so let's do a real life problem for this type of problem. In other words, we want to find a point corresponding, that tilde means corresponding to an area to the left of it. We need to find a point. It could be a z value or it could be an x value, but we need to find a point that corresponds to the area left of it. So problem states that the normal distribution is n 1000, 115. Again, that means mu is 1000 and sigma is 115. Find the 25th percentile. Well, solution, draw a picture. Let's draw the picture. So you see 0.25 is what it means to be the 25th percentile. It means 25% of the data is below that certain point. That's what the 25th percentile is. So this time we know the area, 0.25, and we're trying to find the x value or the data value below it. So you see that line, that vertical line I have? We're trying to find the x1 corresponding to that. So we put that into the calculator again. This time we use a different function, and the function is inverse norm. Inverse norm needs area. So if you give the inverse norm the area, it will give you the value, the area that it's given. It assumes that that area is to the left of the point that you're trying to find. So if you want to find an x value, you would have to supply the mean and standard deviation, which I did in this case, which is 1000, and the standard deviation is 115. So the value that we get is x1 is equal to 922.43. Now, in another real problem, another type of real problem where they actually give you units, when you provide the answer, you'll have to put in the units in there. Now let's go into the next example, example number 5. Here we're trying to find a point that corresponds to an area right of it. So here we go. The problem would be stated something like this. Assume that heights of men are normally distributed with a mean of 70 inches and a standard deviation of 6 inches. Find a height at which 20% of men are above. In other words, you have a point on the x-axis, and to the right of that, 20% of all the data lies. So using the normal model, the area to the right would be 0.2. Don't forget, if you want to use inverse norm, you need the area to the left. So in this case, we have to make an adjustment. So draw the picture. Again, you see the picture comes along like that. Notice my 0.2 is on the right. 20% is on the right. If 20% is on the right, we do know what on the left. So we do know what we can put in the calculator to find that point. It doesn't matter that the point is to the left or the right. What matters is what does the calculator want and what it gives us. So here, when we substitute in the calculator function, we'll substitute 1 minus 0.2 or 0.8. So the arguments would be 0.8, 70, 6. Now you do not have to calculate it ahead of time. You can put it into the calculator as 1 minus 0.2, and the calculator will take care of it for you. If you do leave off the mu and sigma, the calculator is going to assume that they are 0 and 1, and you would not get an x value, you will get a z value. But that doesn't say you cannot use the z value, because you can always convert z values to x values. X equals to, what is the formula? Z equals to x minus mu over sigma. Of course, you could also find the x value, right? Just multiply both sides by sigma and solve for x. So in this case, when we plug that in, we get a 75.05. Something to note is where x1 is, you see the area to the right is 0.2. There's an area of 0.2 to the left of that on the left side. So you could use that as well. The problem is you don't want that x value. You want the opposite of that x value. So in that case, x1 would be, you would have to write this down. I'm going to wait a little bit or slow down. x1 equals minus 1. Let's start all over again. x1 equals minus inverse inv norm open paren 0.2 comma 70 comma 6 close paren. So what's the difference? If you use the 0.2 where the 1 minus 0.2 is, you need to put a negative sign in front of the inv. Okay, so we're done. All we need to do now is summarize. So if you're given a normal distribution with mu and sigma, and you're asked to find the area under the curve, let's suppose that area is A. Well, and you're asked to find the area under the curve between x1 and x2, you first will draw a picture, and then secondly, you would use normal CDF, and normal CDF requires the x1 and the x2. It also requires the mu and the sigma. Now, how about if you want to go the reverse or the inverse? Here we go. You're given a normal distribution, but this time to find the x value or the data value corresponding to that which has an area A to the left of it, we first draw a picture. My picture shows values to the left. So now I'm going to show you what's on the x-axis, which would be my x1 and my mu. And I'm trying to find x1 because I know the shaded area right there. So you say x1 is equal to inverse norm of A mu comma sigma. If you want to find, if you were given an area to the right and you're trying to find that point x1, then you would use inverse norm of 1 minus A comma mu comma sigma. Okay, so again, A is to the left is the normal way we would use this inverse function. Okay, so that's it. Hope you followed. If not, play it again, play it 2 or 3 times till you get it. Practice as you go along. It was nice having you, and hope to see you in another video. Thank you very much.